Hi, my name is Jack Nguyen. I'm your R3 mechanical lead, and in this video, I'll be showing you the starting method for designing. In this case, what we have here is a sprocket and a shaft, and in this case, what the goal of this design will be is to make some sort of mount that could work with the sprocket and shaft. So if you look at the sprocket here, there's four holes. We could check the dimensions of these holes here in this sketch. So each of them are 20 millimeters spaced from the center, so about 40 from both sides, and they all have a hole diameter of 4 millimeters. All right, and for the shaft here, we have the shaft diameter, which we could check in this sketch, so it's going to be 20 millimeters. So that means we need something that could hold a 20 millimeter shaft while mounting or screwing onto this sprocket. So first things first, whenever you are designing something, first thing you're gonna want to do is to do some research. So if I open up here, do some research and search up a sprocket mount. I like to just go on Google Images, take a look at the different options here. So far, there's nothing here. If you look at this sprocket, they already have specific mounts for specific shaft size. But this here would be kind of something that we would be designing. So I like to use Google Images to get some inspiration, something like this, or on YouTube, there's quite a bit of stuff you could. I just recommend researching into the topic. Pictures are the best way to kind of have an understanding of the design, in my opinion. Once you have that done, I'd say start sketching out your design. So on my tablet here, I'll show you, um, I'll be just doing a rough sketch. So what I like to do is I like to sketch out everything that I have. So I have a shaft here. This case, the shaft diameter, so is 20 millimeters, and then the length is supposed to be 200 millimeters. For the sprocket, so no point between the tooth, but for the hole sizing, we know that from here to here, it's about 40 millimeters. Uh, this size here is 4 millimeters, and then this size, which we don't need, but it's just nice to have, is 22 millimeters. Right, so now that we know that, if you go back to the Google image, like I said before, get some ideas on what you kind of want it to look like. In this case, I'm gonna go for simple rotational mount system, so something like this. So I guess I'll start with design, sketching out the design that I will want to make. So it's kind of like a cylinder with a flat plate connected to it. All right. And I would highly recommend sketching it out first, sketching the design out first before actually CADing it. It just helps with saving time, but it honestly depends on what you're doing. Most cases, you'll have to sketch something out as a preliminary concept so that you know what you're going to be making, what it's going to look like, and for other people to kind of gauge, uh, have a sense of what you're going to make. All right, so plate like this, we would need four holes on either side to mount onto these ones here, right? And then the shaft would go into this hole here, so the shaft diameter. So this would have to be roughly 20 millimeters. These holes would all need to be spaced 40 millimeters apart from each other. This is 4 millimeter diameter. But for actually mounting the shaft, so in this case, you have to figure out what the application of your part is going to be for. So in this case, you have kind of two mounting systems on mounting a shaft. So if you look at this image here, there's kind of like a screw hole that goes into the shaft. This case, this is called a set screw. So kind of need a little bit of knowledge before doing some things, but in this case, for shafts, most cases they like to couple. So couple means to kind of fix the it's basically fixing one part to another one, so fixing the rotational parts together. And this set screw lets you kind of combine the two parts together so that when one moves, the other one moves, and it doesn't skip. So um, the actual collar or whatever is being connected doesn't rotate independently from the actual shaft. So one method of coupling it together is by adding a set screw, and then another one uh, that I know would be kind of like a clamp system. So something like this where it's a collar and there's a cutout, and then this, as you tighten the screw, this cutout decreases the diameter of of this whole collar to clamp onto that shaft. So there's a bunch of different versions, variations of that. You could make one like this, which can mount onto a plate because of these four holes here. Um, with the collar though, they're not great with axial moment, since if there's a force that opposes the axle, it can slip since it's just based off of friction, whereas the set screw kind of forces a piece onto the actual um, shaft here. So depends on your application. In this case, we won't be using a clamp system since it's not really linear motion. We're going for more of axial motion. But you can use this for just mounting stuff on and uh, not really twisting it or rotating it. All right, so if we go back to the set screw design, we'll be doing something like this. So if you go into your drawing, basically I'm just going to add a hole that goes straight through to the other side of my shaft collar. In this case, I'm not going to draw the back part just so it's not confusing, but it'd be something like this. In this case, I could choose a size for this. When we're designing stuff for the team, we usually use imperial fasteners. So the holes in this case are 4 millimeters, which stand for M4 screws. With metric systems, really simple, mainly because the sizing starts with the M, and then the millimeter dimension would just be written here. So M4 is 4 millimeters, M6 is 6, and so on. This case, M4 is pretty small, so I'm just gonna make these a little bit bigger. I'm gonna make them 6 millimeters. You can keep changing this until you see what works best. 6 millimeters should be fine for this, so I'll set it to 6. Last thing we need to do is actually figure out the sizing of our part here. So what do we want this huge base dimension to be? What do we want the length to be? And we'll figure that out now. Most of it is trial and error. What you see is best. The way I design for it is depending on the material or manufacturability. Um, so it depends on what we're gonna be making it out of. If it's a 3D printed part, you might have to make it bigger just because it can't take as much force, and it's not too durable as something like aluminum or metal. So if we were to make it out of some type of metal, we can skim it down a little bit compared to what a 3D printed part would be. In this case, I already pre-designed the part just to make sure it works, and I believe, let me check the dimensions here. So I have it set to 55 millimeter diameter and 25 millimeter height. Right. So 25 millimeter diameter. in SolidWorks, the diameter symbols that, so it just helps us figure out what we're actually looking at. You'll learn, if you haven't learned this already, you'll see this in the Mech 222 course, this symbol here. All right, and then the last thing we really need is the height from here to here. We could do that when actually designing the part, so I won't figure that out now. Um, and the actual width of here to here, you'd figure out too. I'm gonna make it consistent, so I set it to 5 mm width. So that's the width of the part. Um, and one final component, or at least feature, that I added to the design was I added ribs. So ribs are kind of a structural component. So if I search it up here, it's just to allow stuff from breaking. So if you see here, it's basically a reinforcement beam that you add onto designs. So in this L bracket here, since it's shaped as an L, it does tend to kind of bend a bit, but adding a rib feature basically prevents it from bending. With our piece here, since it's a plate on a cylinder, if it does have any bending motion of any sort, it can also snap. So I just added it just for added safety. In this case, if you were to make this part, you probably won't need it. It's just nice to have. So ribs would be something like that. And with SolidWorks, making ribs are a little bit finicky, so I can't make them fully flush with the edge. So I have the spacing from the edges to be 0.5 mm, so as close as possible. Um, that's how I figured out the dimension. So now with the sketch here, we could start designing the actual part. So I'll head back into SolidWorks, start a part, open up a custom template that I made, and we can start making the part. So if you look at the part, there's different methods of starting the actual design. You could start by making one flat extrude for the plate, and then a second extrude for the cylinder, and then make the ribs, and then make all four ribs, something like that. Do all the cutouts. It's different methods, but when you're designing, you want to design it as quick as possible, so the least amount of features. In this case, I start with a revolve sketch to make the plate and cylinder. So I start with the L shape here, set the dimensions so we know the inner diameter is going to be 20 here. And in this case, I set it to 10 since it's going to be a revolve about the origin. So it'd be 20 total. So if I select that again, set it to 10. In SolidWorks, you could also add equations by changing the name. So I could do shaft diameter, write that out, and then set the dimension. And if I want to reuse that dimension there, I could just put a dimension, make it equal to shaft, or go global variable, and you could choose shaft diameter and just refer to it later on. It's a little handy, very useful. Um, this is 25. From here to here, it's going to be 55 divided by 2. There's also algorithms that let you put equations into SolidWorks and it will just equate the dimensions for you. So save you some time so you don't have to do the math in your head. So we have 55 down, 25 down. You can start striking them if that helps you. I'm going to do that here. All right. We also have the thickness of the part. I set that to 5. In this case, since we know both of the thicknesses are the same, I could also use a relation here. So if I click this, hold control, click this, I could add a relation, make them equal. So now both of those are equal, and we pretty much have most of the um, dimensions down already. So We have four down. We have four more left, so halfway done the part already. With the revolve tool, you have to remember to add a line or a axis for the actual part to revolve around. So I just added a center line here. Click revolve boss base. It will automatically select the last line you created, so this line here, and make the revolve. So you see I made the first main part here using just a revolve tool. Next thing we'll do is make the holes in the plate. So these four holes here. So I'll make the circle first, set it to the respective diameter, and then set the distance, which is supposed to be 20 millimeters from the center, or 40 apart. So I could start deleting that. All right, and there's four of them, so that means we need to um, create three more. In this case, instead of making four other circles and dimensioning them all, I'm going to use the circular sketch pattern. Select the circle. It will automatically choose the origin and then choose the quantity and click check. Alright, so if you see here, I could still move it. That's just because this origin hasn't been set. Set that there, and in this case I want to still fix it since I can still revolve it. So what I'll do is I'll select this point here, select this circle here, and choose horizontal, so it will make the two origins horizontally straight with each other, as you can see with this line. Now you could choose the extrude cut tool and cut these holes. If you see it automatically goes in the opposite direction, you would choose this here, click on that button, and then it'll flip it. If you know the depth of the part, you could set it here, or you could just choose up to next, and it will only extrude up to the next face that it sees. And we have the holes for the sprocket. Next, we want that hole that goes, the set screw hole. So I could actually, we'll add the rib first. So for the ribs, you would choose a plane that goes um, through the side of the revolve here. So in this case, not the top plane, since that's parallel with the bottom part, which is either the front or the right. I'll choose the front in this case. It doesn't matter too much. And then it's pretty simple with the rib tool. You just draw a line from one part to one face to the other face. I also dimensioned them to be 0.5 away from the face. So 0.5 there, 0.5, so 0.5 millimeters from the edge. And if you go in the image, you can delete that off. So 0.5 is good. And then now all you do is you go to features, click on rib, set the width of the rib. So that's something that I didn't put down here, but in this case we want these to be about 5 millimeter width. So 5 millimeters. This case set to 5, and then I chose well, it automatically chose both sides because you want it to be even. And then you have to make sure this arrow is pointing downwards and not upwards. You could switch that here by clicking flip material side. Click the check mark, and it creates a rip here for you. You could repeat that again for all four, or you could just use the circular pattern tool. So select circular pattern while having the rib feature selected. So I'll show you that again. My rib feature is selected, and then circular pattern. It will automatically put in features and faces here. And then now for the direction. So in this case, it wants a axis for it to revolve around. We didn't draw any in this case, but we had one previously when we did the revolve tool. So you could go onto your uh, show item tab, click on the drop bar, and choose view temporary axes. And you would choose this temporary one, which was the one you made previously for this revolve. Click check, and it adds those ribs in for you. Now for the final piece is to add that hole for the set screw. So this case, I'm gonna make the hole through all so that you could add two set screws, and you can't really add it here. You would have to add it on this side, which is parallel to these holes. If you look at your planes, you don't have any planes that are like that, so you would need to actually create your own plane. So if you go to reference geometry, select planes, it requires you to choose different references. In this case, we only need two. Most of the plane tool, at least the plane tool, requires you to have two minimum. So first one will be the front plane, and then I want it to be 45 degrees from the front plane. So I'll choose this uh, tool here at angle, set to 45, and then the second reference would mean where you want it to rotate about. So I'll rotate it about that temporary axis that I created before, and choose that there. Click yes, and now we have a plane that's 45 degrees from the front plane. You could select this plane, click sketch, and now make a sketch of the circle cutout that you needed from for the set screw. In this case, we said the diameter was going to be 6, so I could also name this too to be M6 if we do want to refer to it again. So 6 millimeters. I want it to be aligned with this here, so I'll choose those two and then click uh, where is it? Click that and click horizontal. And so now it's horizontally fixed. And then I also have to choose the height for it. So for the height, I'll click on Smart Dimension, go here to here, and in this case, I'm just going to choose an arbitrary number of 7.5 millimeters to extrude cut through both, so on both sides. Click yes, and in this case, it looks pretty good. Doesn't look like it will interfere with a bolt head if it were to be screwed here. So overall, this is a pretty decent height, and yeah, I'll just set it as that there. You could hide the plane so you don't have to see it again by right clicking and clicking the eyeball. And now we have the finished part here. So to finish it off, we'll put this in a assembly to confirm that everything we made works. So you can click on file, click on make assembly from part, or you could click uh, on the drop down here, do the same thing. Save the part first. In this case, I already made it previously, so I'll just rename my previous edition. And then select all of the components that you want to make. And if we made this correctly, everything should fit. Make sure that everything's floating. So I'll start with mating this onto here. For this plate here, you only need 3 mates total for it to be fully fixed together. So they're fully fixed together. And then for the shaft, you only need 2 since a concentric counts as 1. Now if you see this sprocket has been fully fixed to the shaft just by the mates. And in the real world, you would also add the um, fasteners that you're using, so bolts, nuts, set screws. You would dimension the specific holes to fit um, a thread if you did need it to be threaded. So in this case, the set screw hole would be threaded, and you would probably use a thread feature to add that here. In this case, we aren't, just for the sake of time. And then same thing here, if these sprockets are threaded, you gotta make sure that there's enough spacing in this hole so that the bolt could just run through. And that's something called tolerance. I didn't show you that today, but you'll be learning that in a future course, so um, you won't have to worry about it in this case. I hope you learned a few tips and tricks from this video. I hope you enjoyed the video as well, and I'll see you in the next one.